Alright, let's talk about the range sum query mutable. So you are given an array nums and you have to handle the multiple queries of the following type. So you either update it and you either calculate the sum between the range based on the left and right. And then there are three functions you need to write. So one is constructor, the other one is update, and then the last one is some range, right? So just read over it, and then if you just create an array, something like this, right? If you say in array sum, and then you basically use a prefix sum to actually do this. This is fine, but the problem is the constraint is what is too complex, and then you will not be able to solve it, and then you'll get TLE right away. So again, go on the Git for Git. So there's a segment tree idea. So in this idea, it's pretty simple. You will definitely need to know this is an array, right? So I build a tree based on my in array, and then for the parent is actually the sum of the children. So 1 plus 3 is actually equal to 4, and this is for 0 and 1 index, and this is value 5. So 4 plus 5 equal to 9. This is between 0 and 2 index, and then so on, right? So you definitely know the idea. So you basically need to create a tree node, right? Tree node class, and then you will need to have what? The sum for the variable, and then the left and right for the range, and also the pointer when you point at your children, right? So I'm going to say class tree node, and I need to say in sum in left, sum left, and then right. In this case, I'm not going to use left and right because I will say my pointer tree node left and right here. So this will be what? Starting and ending. Start index and end index. Okay, this is much more easier for you to read it. So for every single time when I construct a tree node, right, I will assign an index. And then the index is going to be based on my value, right? Based on my input. If I assign the index, in the div, right? This is going to be 0, 0. So I will assign star equal to 0 and equal to 0. And then if I assign the index right over here, this is going to be 0 and 2. So this is based on my just based on my function, how I assign, right? So this is star. This actually equal to star, and then this star n equal to n. Alright, the tree node is pretty simple, and I just have to create a tree node root, and then I need to just assign the root equal to what? The build tree. I need to pass in the what? I need to pass in my nums and pass in my index. So index is based on 0 to what? Nums of length minus 1. Nums of length minus 1. Alright. So again, you need a helper function called build tree, and then the type is tree node, right? Public tree node, and then I'm going to call build tree, right? I need to pass in the nums array, the start index, and the end index, right? So if the star is what is greater than n, you just basically return null. This is not doable, right? Alright, so back to the normal case. I need to create a tree node. If I want to create in the tree, right? So tree node. Null equal to new tree, null, and the range is star and n. I don't care which one I am assigning, because when I pass in the value between 0, 5, right? 0, 5 with the in array, I need to know this is definitely a range between 0, 5. So I will assign it right away. The problem is I need to assign what? I need to assign the sum later, right? I need to calculate all of the possible value all the way to the bottom, and then recursively calling back. I need to find out what is my children value, and if I know my children value, I will be able to know my parent value, right? So I will just keep updating my the sum for the tree node when I call it back. So what if is the root if the star is actually to the end, which is the leaf, right? I will just assign node.sum equal to what? Num set star, and then I will just return none. Again, else, right? So if I have the array like really long, so when I assign the first if statement, this is the base case. This is the leaf case. So what happens if the tree node is not a leaf, right? So I need to say int mid equal to what? Star plus n minus star divided by 2. So this is a habit you need to you need to have it, right? When you're doing the binary search, you would be able to know this should be avoid the stack overflow and something else. If a value is negative, then you will get a wrong answer for sure. And I know the tree doesn't have the negative value because I assigned a 0 to the positive number. So what if the value is negative? A different question, right? You definitely want to avoid the stack overflow or out of index stuff. So you just keep the habit right over here, and then I need to assign my left based on my index. So I'm going to say build tree, right? Build tree. I need to pass in the nums. I need to pass in the star. I need to pass in the mid only. And then note that right is going to be what? Build tree. Again, pass in a num, pass in mid plus 1, pass in the n. Right? So the reason why I use mid plus 1, this is because I want to assign my next value, the next value after the mid to the right side, and then the mid should be on my left. Alright. So at the end, now I know this is not a leaf, so I need to say node.sum equal to node.left.sum plus node.right.sum. And then I would return no, right? Again, if you return no over here and then return no over here, you can probably return no over here, right? Alright, so this is pretty much the build tree idea. Using a recursion solution, so this is pretty much like merge sort, right? But think about this, right? They are probably similar, but not exactly the same. And then for the update, right? For the update, it's easier than some branch, to be honest. So I'm still going to ask a helper function. This is because I need to pass in the tree node root. And then I need to what? I need to call the helper function root index val. Alright, so for the update, if the tree node is actually equal to the leaf, right? Root.left, root.star, sorry, root.star is actually equal to root.n. This is the leaf, right? So I will just update my val. So root.sum equal to val, and then I will return. Alright, so this is the index, right? Again, I just want to point out again, this is what? 0, 0. This is 1, 1. This is 2, 2. So when I said root.left equal to root.right, root.star equal to root.n, sorry, root.star equal to root.n, I know this is a leaf. And then I need to update this to what? To probably 20, something like this. And then when I recursively going back to the top, I need to update my parent. This should be 24, right? And then this should be what? 51. Alright. So this is it, right? I don't have to change the index. The index is still 2, but I need to change the value, right? For the tree node. And then this is it, right? So again, if you want to find out the index you are looking for the tree, so from the top, right? From the top, you need to know you either going left or you either going right. This will help you to save a lot of time using log-n solution. Without traversing from the left to the right, this is all of them. If you're using log-n, right, this is much more efficient. So I will be able to know if my mid is actually equal to the root of star plus root of n minus root of star divided by 2. So again, for every single node I build, in the build tree function, I already assign my what? My start and then my end, right? And this is it, right? So let me come back here. So now I need to know if the index is less than or equal to the mid. This is on the left side, right? So I will say update root of left, comma, index val. Again, for the right, index val. Okay, there is something wrong. Update root of right, index val. Then I need to update my what? My sum, right? So root of sum is actually equal to root of left of sum plus root of right of sum. So this is it. And then I need to write my sum range function. So sum range function is pretty much the same. I need to pass in the root, I need to pass in left, I need to pass in the right. Alright, so what else? So I need to create a helper function for the int, right? And if this is the case, I'm going to return, right? Int sum range tree node root in left in right. Alright, so let me scroll down a little bit. Alright, so if I know the sum range, alright, I'm gonna just give an example. If I want to know what is the range between 0 to 2, I will just go on my left and I know this is my value. I'm sorry, this is my range for the value, right? So I will return 9 right away. And this is easy. And for more simple one, you just go on the leaf. So I want to know what is the value between 2 to 2. And then you will say, okay, this is fine. This is easy as well. Then what happens if you want to find out what? The value between 2, 4. So what is 2, 4? So the 2, 4 is actually, this is index 2, this is index 3, this is index 4, right? I want to know the value, the sum for these 3 values. But this is a tree, right? And then for every single tree, you know the range for 0, 2. And then you need to what? You need to get rid of this. So you want to say, I only want this. I only want this. And then when you traversing to the top, right? You need to what? You need to avoid others index value, right? And here we go. So let me start coding. So again, for the base case, if the star is actually to the left and also root of right, root of n, sorry, equal to right, then you'll return root of sum. And what else? Nothing else. So I can say what? I have to find out the midpoint if I want to know which side of the tree I'm looking at. It's either left or either right, right? So I'm saying in main equal to what? Root of star plus root of n minus root of star divided by 2. Yeah. So if I know the index, and there are 4 different scenarios, right? This is made. So what's the first scenario? If the left is right over here, this is first scenario. If the left is right over here, this is another one. If the right is right over here, this is the third one. If the right is right over here, this is the fourth one, right? So I will be able to know which one I should be able to find. So for the right, which is less than or equal to what? For the right, which is less than or equal to the mid. This one is referring to what? This one, right? So this is on the left side of the tree, so I will say go left. Again, if the left is greater than the mid, which is this one, right? Then this is going right. Alright, so these are supposed to be what? These are supposed to be the base case. So imagine here. So this is 0, 5, right? And then you want to find out 0, 1. And then 1 is less than what? Less than the mid. The mid is what? 5 divided by 2, which is 2. So you will know the entire searching is on my left side. And then exactly going to be the similar stuff for the right. If the mid is less than L, the entire thing is going on my right. And this is easy. But what if you want to say, you want to find out the range between, the range between 2, 4, right? This is hard. So you want to know what is the range between here. And again, you only need to grab 2 and then 3, 4 in each side of the tree, right? So for the 2 on the left side, for the 3 and 4 index on the right side only, right? So from here, I need to say if the right is less than equal to the mid, this is easy. Just go on my left, and this is left and right. And then again, else if the left is what? Greater than the mid. This is on my right side. Alright, so everything else should be hard, right? Should be hard. And then I will have to say return some range. I was just looking for the value itself. So root of left, comma, mid, plus some range, root of right, mid plus 1, comma, and then this should be n, right? And then the n should be right, if I am correct, right? And then this is going to be pretty much it, right? So hopefully I don't make mistake, but this is supposed to be the solution. Alright, I pass the test again. So let's talk about the time and space. Alright, for the space is really really simple. So you are building a tree, right? So this is a tree, and then the n represents the length of the array. So this is what? 1, 2, 3, 4, 5, 6. And then how many nodes you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So I mean, again, this is going to be based on how you build a tree. Be honest, you probably will build a binary 4 tree, or a balanced tree, or unbalanced tree, right? It doesn't matter depending on how you build it, right? So again, I will not say this is supposed to be a complex solution for the space. I would say it's all of n. All of n represent length of the array. And then the time for the build tree. I would say it's all of n, right? Even though that you have a parent and then you're just constructing the sum of the value between your left and right, but it doesn't matter. I'm going to say all of n for the time for the build tree. And for the update, this is going to be log n, right? You cut it into the half every single time using the mid, and this is log n. And then for the sum range, this is going to be log n for the time, right? You don't allocate any space in these two functions. So this is a solution, and I know this is kind of long, and this question is supposed to be difficult. And I will see you next time. So if you feel this is helpful, subscribe, like, and I will see you next time. Bye.